implement the energy efficiency program, which was what we're talking about today. So just a bit of background. Most of you might remember me from my time at Department of Planning. I was there for 14 years, first as a planning officer and then as manager for operations, providing training in OPS, managing the admin team, leading public education campaigns, then moved over into the ministry to assist with the coordination of the implementation of the National Energy Policy, of which this is an initiative. So for the past 2 years, we have been implementing an energy efficiency program, which was funded by the European Union under their RESEMBID program. And this funding was used to conduct energy audits on public sector and residential buildings, retrofit buildings with insulation and energy efficiency, energy efficient AC, and develop energy efficiency guidelines. Full details of the program are available on our website. We've got a program highlight guide, a case study, and a video. So thanks to the funding from the EU, we were able to contract technical experts, Econoler, to develop these energy efficiency guidelines and the homeowner infographic. They were developed in consultation with the Ministry of Planning, Agriculture, Housing, Infrastructure, Transport and Development, the Department of Planning, CUC, the Cayman Society of Architects, Surveyors and Engineers, and the Cayman Contractors Association. So we liaised with them as we were doing these guidelines, and now we wish to share them with you, the key stakeholders that are in the field and can provide valuable insight into the achievability of implementing these guidelines. Next slide, please. So the energy efficiency program is part of the implementation of the National Energy Policy. When we wrote the project proposal to submit for funding, we referenced all of these strategies from the policy. I know when people hear energy policy, the first thing they think of is solar, but there are so many other strategies, and the energy efficiency is a big part of this policy. So there were several strategies that we were able to link to within the policy. Next slide. Our ministry also just recently approved the climate change policy, which touches on making our island more resilient, which is what energy efficiency is, making our buildings resilient to climate change. To support making our buildings resilient, in 2022, Cabinet approved 0% duty for energy efficient construction materials, including spray foam, insulation, foam sheets, low E-film, smart thermostats, and home energy monitors. We're now working to get 0% for energy efficient air conditioning units. Next slide. We have implemented several energy efficiency projects over the last 5 years. The first being the Cayman Home Energy Makeover, which we did in 2020 as part of a public education campaign on energy efficiency. We invited residents to a free giveaway for a home energy makeover. 800 residents entered, 8 received the free energy audit, and 1 received the free makeover with installation, sponsored and installed by Foam Pros, and AC provided by CEL and installed by Cooling Pros. We then did the residential energy efficiency program, which was funded by RESEMBID, and this included an energy audit and retrofit of 10 residential buildings with R30 installation and 20 SEER energy efficient AC units. We also did an energy audit of 13 public sector buildings, and we retrofitted to the West Bay Library and the airport post office. We also developed and implemented a CHEER program, which stands for the Cayman Home Energy Efficiency Retrofit Program, which was open to all low-income residents. 100 applied. We selected 29, and 12 have been retrofitted so far with insulation and air conditioning. So next slide shows the graphs of the impacts from the retrofit. So this was the first home we retrofitted. You can see from the orange line, which was 2021, where the energy consumption was still quite high. The first green line shows when the spray foam was installed in March. It still kept going up, and we were wondering why. And now that we can look back, we can see, well, we insulated with, I think it was like R21. Now we're seeing that R30 is the recommended insulation. And so when we installed the AC in September, dramatic drop. And the blue line in 2022 shows that the energy consumption remained low because of just insulation and air conditioning. Next slide, please. And then this is a NHDT homeowner where we retrofitted one of their homes. And you can see the red star is when we installed the insulation, and the faint blue star is when we installed in August, when we installed the air conditioning. And you can see the dramatic drop, especially in November, December, dropping from 1,300 kilowatt hours down to just over 400. So we've seen the power of just insulating insulation and air conditioning. We're continuing to monitor the consumption every month to keep the data and to help build more programs. Do we have that video? I'm just going to show you the video summary of the project that we did.
I guess I don't know who.
I can show it.
Okay, thank you. So I'll stop sharing.
I'm not hearing any sound.
You need to unmute, Alex. Or
Okay,
you need to do something to share the sound. Yeah.
Can you hear it now?
Nope.
No.
No, I think there's something you need to do.
Yeah, I'll reshare. I think it's in the sharing settings. Sorry about that. Good sound. There we go.
Welcome to the Cayman Islands,
Yes.
where community and sustainability meet. Today, we explore the transformative residential energy efficiency program funded by the European Union through the Resembid initiative and in collaboration with Expertise France. This program focuses on the heart of the community, its homeowners, like Miss Veronica Ebanks.
I'm a single mom not working, and it's very hard on me. My last energy bill here is $419 and some change. Like the water is $56 and change. It's hard. Very hard because I am not working right now. And it's very hard.
Just retired, not working, and to know that the program helped me with this and praying that, the bill go down really, really low. At least, whatever little change I have, I'll save.
This program aims to retrofit homes with advanced, energy-efficient technologies like solar panels, appliances, and insulation. The EU awarded the ministry more than €911,000 in 2022 for the program, which was open to those who own their homes through the National Housing Development Trust. In 2023, energy consultants David Barnett and Jan Garno arrived on island. Their mandate was simple: conduct energy audits through 10 homes, train others through the energy audit training component of the program, and make recommendations on how the homeowners could save energy.
The main objective really is to go through the technical assessments, to get the data, and then interact with people here so that they have a sense of what energy efficiency is about and audits are about. Later on, we'll begin to do the reports. So ultimately, the reports will then inform residential entities of their energy use, the opportunities that they'll have to reduce the consumption of energy, their financial savings in that regard.
It also aimed to raise awareness about the importance of sustainability in the Cayman Islands community and how even small changes can make a big impact.
If everyone was knowledgeable about energy efficiency, then they would make the right choices. So it's really about raising awareness.
Energy audits conducted across homes identified critical inefficiencies outdated appliances and inadequate insulation leading the list.
You know, we visited some of the homes, and the comment that kept coming back is, wow, you know, I've stopped using my dryer because it's just too expensive. I've stopped using my electric stove because it's too expensive. But if you help them to understand that by using more efficient technology and changing their behavior, they can actually reduce their costs, that gets people excited.
They compiled their findings in a report and made recommendations to the ministry. The reaction was swift. Through the program, the homes were retrofit with solar panels, energy-efficient AC units, and foam insulation. After an open procurement process, the ministry selected Parsons AC, EcoHouse, and ProSolar to serve as suppliers and carry out the retrofits. Since they were installed, Ms. Joy and Ms. Veronica have seen significant energy savings, as have all the homeowners.
Oh, I'm ecstatic. I'm really, really over the hill. They're doing a wonderful thing for the community.
Meanwhile, the training aspect provided local leaders from the public and private sectors a better understanding of what energy audits are and how to conduct them.
They made it all relevant to Cayman, and it was very interesting, and you could see how what decisions you made day to day could impact your energy usage and costs and things like that.
It's been a wonderful experience because I'm actually developing a more detailed eye of the energy audit process, basically, and actually developing the skills that are needed for professional auditors.
Through several campaigns, the ministry also engaged the public to raise awareness of the benefits of energy efficiency. Econoler also produced a homeowner's guide and contractor's guide available on the ministry's website. Through dedication and community effort, the residential energy efficiency program not only reduces costs and conserves energy, but also sets a precedent for future generations in the Cayman Islands.
All right, so I hope that provided you with a good summary of what we're doing and why we're doing it. So the end goal is to make the guidelines a policy, but for now we're leaving it as guidelines so that we can monitor the impacts and make changes if necessary. Because what we've found in our discussions with stakeholders of the last 2 years is a difference in opinion in our value for insulation, type of insulation, closed cell, open cell, SEER rating. So we've taken all that information and put it together to hopefully make sure that we're all on the same path. And when we hope that when you start to implement these practices, you will share with us what works, what doesn't work, cost differences, positive and negative impacts, so that we can build on our knowledge of how we can help residents to reduce our energy consumption and therefore their utility bills. So you all play a very important part in helping residents reduce their cost of living, from the initial design of the building to selecting the right material and appliances to the follow-up maintenance, which is absolutely key. So thank you so much for joining us. We will be taking short breaks throughout the session and recording it to make it available in case you do miss anything. I now turn it over to Shondell Bodden from the Ministry of Planning, Agriculture, Housing, Infrastructure, and Transport and Development, who has been working with us by providing his expertise in the building code. So Shondell, over to you.
I'm sorry, can you all hear me now? Yes, good morning all. And Kristen, thank you very much. The Ministry of Planning, Housing and Infrastructure, Transport and Development, and the Department of Planning supports this initiative and is happy to collaborate with the Ministry of Sustainability, Climate, Resilience and Wellness. Energy efficiency is about using less energy to get the same job done while cutting energy bills and reducing pollution in the process. Oftentimes, homes and other structures use more energy than they actually need through inefficiencies and energy waste. Incorporating energy efficiency is perhaps one of the easiest way to eliminate energy waste and lower energy cost. It is also one of the most cost-effective ways to reduce air pollution, help families meet their budgets, and help business improve their bottom lines. We are seeing the Cayman Islands consumers and businesses choose or invest in more energy efficiency products. Wherever energy is used, there is certainly an opportunity to improve on efficiencies. Today's session is really about collaborating and sharing information with stakeholders, which will help achieve and improve energy efficiency in our homes. These guidelines are in line with the government's.
We lost you. You hit mute by accident.
Okay, sorry, my apologies. These these sessions is about collaborating and sharing information with stakeholders, which will help achieve and improve energy efficiency in our homes. These guidelines are in line with the government's national energy policy, namely those that are in particular in Section 3, which covers efficiency relating to homes and sets out the strategies and the frameworks in order for that to be achieved. So on those basis, again, we are certainly happy to participate in this and commend the Kristen and her team for the commendable work that they have been doing. Thank you, Kristen.
Thank you so much, Shondell. I'm now going to turn it over to Econoler, who's an energy consulting firm from Canada. They've been working with us for several months. They also conducted the energy audits on the 10 buildings, residential buildings, and the 13 public sector buildings, and developed the training program. They visited the island last year to meet with several stakeholders, and now they're online to take us through the guidelines. So I pass it over to you.
Thank you, Kristen. You can hear me? Yes. So, well, welcome everyone to this training. I'd like to thank the ministry for their collaboration. It was great to working with the team, and we they provided us all the data and also access to homeowners, so we can really perform those audits, and also access to all relevant stakeholders, so we could conduct consultations and prepare this guideline. So, well, I'm Stephanie Noor. I'm team leader for this project, and I was a trainer for the previous one. And I'm with Meton and Alex, who will introduce themselves when they come in and present the training, because they will be mostly talking to you to train you on this guideline. So, so the guideline is intended for residential construction, and the training will introduce you to the guideline. Of course, the guideline I'll show you in a minute. It's available on the website. So some ideas may be new to you, maybe some of the approaches as well, but we have a lot of experience. Econoler is, yes, a Canadian consulting firm, but we have more than 30 years experience in the Caribbean. We worked a little bit everywhere, from Cuba to Trinidad and Tobago, and now very happy to have worked in the Cayman Island. And so we know really well the challenges that are faced by the islands. And also we understand how much energy and energy cost is a burden for all sectors, residential sectors, but also for the commercial sector, for public buildings, etc. So we have set aside some Q&A at the end of the training, but please feel free to either write in the chat or raise your hand virtually if something is not clear. Or if you want to have, if you want to ask a question during the training, like Kristen said, we will have a break, some breaks as well. So no, we can also take the time before or after the break to answer questions. this guideline, like Kristen mentioned, it is intended to eventually be kind of converted into a policy or a regulation. So it really sets the table for energy efficient technologies, but also building design, um, and also focusing on construction. So we really go from the outside, so the building all the way to the inside, and also the equipments and also the energy use. The guideline is in two sections. There's a section on new construction and another one on retrofit. Of course, a lot of the recommendations can be applied to both. And when we present during the training, we will inform you if some of the recommendations are only for new constructions and if other ones can be applied to both. You will also learn about the CARICOM Regional Energy Efficiency Building Code, which is a building code that exists in all CARICOM countries. It's not necessarily adopted by all countries, but it has been done for those countries, and a lot of them have similar climate to Cayman Island. And also, just so you know, it will even be updated very shortly because I think the World Bank has launched a request for proposal for updating it. So to be really up to date with the more recent materials that exist in the region, also to take into account cost change on those materials or on equipment. So even knowing now that this code will be updated, it will be even more relevant to get knowledge of it and maybe eventually to adopt it. So don't worry, like I wrote in the chat, the training material will be available in electronic form after the training. This training is being recorded, so it will also be available on the ministry website, and you already have the guidelines, and here it is. So this is the energy efficiency guideline. You have the link right here, and the guidelines are already available on the website, and also the energy efficiency infographics that was prepared for actually the residential sector. So do you know that although there's a guideline which is more intended, let me see if they've been downloaded. So maybe just in very quickly, so you can have an idea of what it looks like. Maybe you have seen it. So this is the energy efficiency infographics that is intended for homeowners. So they will be also informed about the potential for energy saving and what they can do in their house, either an existing house or a new one that will be built. So don't be surprised if you have some homeowners coming to you and saying, hey, is my air conditioning efficient? Or have you thought about using, I want a light color exterior finish because I know it's more energy efficient. Don't be surprised. It's probably because they've read that homeowner infographics. And the energy efficiency guideline that has been issued in collaboration, of course, that's the ministry in collaboration with Econoler. So you have all the information here, and this is what we will present today. So we will kind of digest the information for you, so you know what's more important, and also the highlights of this guideline. So here's the training content. Very quickly, we'll give some type of introduction on energy efficiency, although Kristen has already done it very well. We'll talk about some design strategies, an introduction on energy efficiency standards at code, as focusing especially on the CARICOM EE building code, and then look at the appliances, the systems, so the energy using equipment, especially focusing on air conditioning, which is the highest energy consuming equipment. And then also look at water, because when you save on water, well, you save also on energy. and water is a scarce resource, so we also look at it on that point of view. Talk about retrofitting, and then we'll have some type of interactive session with some case studies and Q&A and wrap up. And we'll have a post training survey. I hope most of you have filled the pre-training survey that I sent yesterday evening, and we'd like you to also fill the after training survey, so we know if we can kind of measure if the training has been useful, and also evaluate if there's other training needs. So, like I said, the guideline is in 2 sections for new construction and retrofit, because although you may see some repetition, we thought that when someone consults the guidelines and they have a specific case, okay, I want to retrofit a house, they don't want to go through the full guidelines. So you can go right away to the retrofit section and you'll find all the relevant information and recommendation there. So we have a little poll, since maybe the people who have filled the pre-training survey are not exactly the same as the one in this training. So I think Alex will launch the little survey or the poll, just so you can tick from which residential construction industry you come from. Either a builders, a consultant, a ministry. So I don't know, you're supposed to see the poll popping up in front of you. So I don't know if it's happening.
Yes,
maybe
it's happening.
It's happening. Yay!
Yeah.
So me and Alex don't feel it because you don't fit anywhere, but everyone else, if you can please take 1 minute, and then we can show the results because it's live. I guess if I go here and I go in the chat, so we can see the answers now live. 20 answers. So please just tick here. If you're in the ministry, just tick on Government of Cayman Island. I'm happy to see there's not too many others. So meaning we've covered a lot of the categories. "24, how many people? We have 45 participants, so we're supposed to get 43 answers, at least. So I'll wait a little bit, 27, just so maybe I'll continue a little. I'll continue on the presentation meanwhile, and I'll come back to you. Again, the guideline the aim is to really focus on areas that will provide the most significant impacts on energy consumption and an energy bill for the residential sector. And like Kristen said, this guideline, yes, was prepared by Econoler experts, but really in consultation with stakeholders. Alex spent a week and has met several of you to be sure that it's applicable for the Cayman Island context. Of course, there may be room for improvement. No, it's not something that is fixed in time, but I think already starting with following this guideline will definitely decrease energy consumption by the residential sector and improve the quality of life, and also improve economic situation of the homeowners. So the target audience of the guideline, it's pretty much all stakeholders involved in either defining policies for the residential sector, the stakeholders involved in planning the residential construction, in building the construction as well, in designing the systems, also operation managers in, like, for example, in apartment buildings or condominiums, and also appliance and equipment retailers and suppliers, because yes, we look at the building itself how it's positioned, how it's built, but also at the equipment that are being installed in the house. For now, this guideline, of course, is not mandatory, but we strongly encourage everyone to adopt it and to use it, because the intention is to use this guideline as a base for a policy, being either standards, being a building code. So we are encouraging everyone here to start using this guideline starting tomorrow, because it will also prepare the market. And when a policy comes into place, meaning with mandatory measures, it won't come by surprise. You will already have applied those measures, and it will be a nice and easy way to move to a mandatory policy to improve residential construction. Here's a timeline. So I've highlighted in blue what is you as stakeholders out of the government. Let me say what will be the impact on you. So right now we are in March. So as you can see, promoting the homeowner infographic, the awareness, all of this is being done by the government. The training the stakeholders, this is where we are. So the guideline has been launched, it's public, it's on the website. We're training the stakeholders. And meanwhile, the government will be elaborating some measures and incentive to support the stakeholders to use the guideline. And one of your job that will be very important to be able to ensure that those guidelines are relevant is helping the government collecting data on compliant projects, or even if it complies with only one recommendation. Because as you saw earlier, just seeing, okay, you insulate a house, you see the cost is reduced, you install an efficient AC, you can see that the cost is reduced. To gather data on this and to be able, will enable to prepare a very precise and very appropriate policy later on. So collecting data on how much does it cost, how much energy is being saved, how much energy in cost is being saved by implementing, by following the recommendations, will help a lot, the government, but the society in general, to improve the residential construction. And it will help also plan maybe another guideline eventually for public and commercial buildings, because this is just a starting point. Now, the residential sector, but there's all the other buildings on the island that could also be built in a more efficient way to save energy. So, of course, this takes time. And this is why the timeline for the implementation of the guideline and really collecting data over a year, it's the recommended time. And then the analysis of data will be done slowly but surely by the ministry. And eventually, probably in 2026, there will be a policy issued. But of course, it will all depend on how well does it go, and how well it is implemented, and if it's well accepted in the market. So maybe I'll just go back to our breakdown. So we have a lot of architects and designer, which is great. Builders and project developer, about 10, so about 27%. Some technology supplier, but we have a second training that is planned next week. That will focus especially on standard and labeling and equipment. And of course, this training will be more interesting for technology and material supplier, people from the government, and 2% from utilities. So, well, you're all welcome, and we hope it will be useful. So I think from now, sorry. Yeah, I will pass it on to my colleague, Niton, who will introduce himself and also continue with the more technical part of the training. So enjoy and don't hesitate to ask questions if there's anything. Me, over to you.
Hi, yes, thank you, Stephanie. That is, I hope that gives a good introduction to what we're trying to do today, and also for the training, for the implementation overall. I think one of the things that we also wanted to mention is that, in adopting the code, one of the feedback that the government will also want to hear from you is whether or not some of the recommended measures that the guide contains, whether or not there's enough equipment or suppliers, your ability to secure some of these equipment or what have you, and that will also be useful feedback, because if it's a recommended or eventually some sort of requirement, but if you're unable to obtain the right equipment or materials to comply, then it becomes very difficult, a very difficult challenge. So it's something else to keep in mind. Anyway, my name is Miton, and happy spring. Today's the first day of spring for everyone. You might not notice it. We don't notice it either, because it still looks like winter outside for me, and I think it was still snowing in Quebec for Stephanie. So, but anyway, it's definitely something for us to look forward to. Another thing, just quickly, we have changed the content around just slightly. We were going to put the design part before this, but we decided it actually makes sense to just talk about the building codes and just the coverage and get that out of the way. Then we can more focus on the other measures that the guide contains. So it's not quite it's not quite the same flow as the guide, but hopefully I think this makes more sense, and this also hopefully will, depending on your appetite, we can be more technical as needed as well. Anyway, so I'm Miton. I'm based in the U.S., actually, Portland, Oregon, and I have about over 20 years experience in energy efficiency and residential energy efficiency. But that doesn't mean that I know everything. I've learned quite a lot in working on this project with many of the local stakeholders, and hopefully we've reflected some of that in the presentation of the guide. So now I'm going to go ahead and start my presentation on codes and standards, and also share my screen. So let's see if everyone can see my screen. Great. Great. So we've discussed the International Building Code and this Caribbean Region Energy Efficiency Building Codes. And all of that information flows from an international organization. It's the International Code Council, and they are a group of professionals that develop model codes and standards that are used in building design. And of course, one of the standards and codes they've developed is the IBC, the International Building Code. And the International Building Code establishes minimum requirements for both design and construction of buildings, and they focus on many aspects, including structural integrity, fire prevention, accessibility, and also energy efficiency, which is all very important parts of the construction sector. and you know, they also, they've taken many other things in consideration, and it's developed in such a way that it's like a menu. You can pick different sections of the code to adopt, and also phase in. So you can pick more important parts like structural integrity and fire prevention, and eventually phase that into the national code works. In terms of the Caribbean Community Regional Energy Efficiency Building Code, it was developed by CARICOM, the Caribbean Community, which is a group of Caribbean island nations. And what they wanted to do is to promote uniform code energy efficiency standards across all as many Caribbean nations as possible. So the CREEBC is the international building code, but it's tailored for tropical climates. So there's some key differences when you tailor the code to the Caribbean climate. Of course, you have to adapt to the climate of the Caribbean. So it emphasizes measures that are more applicable for warm and humid tropical conditions, such as improved cooling efficiency, ventilation. It also look at, remember we talked about the code actually also emphasized things like structural integrity. And it takes into account the fact that, we in the Caribbean experience many storms, some strong ones. So that is also taken into account. They also take, what is seen as the regional energy goal. So the CARICOM has some common goals for energy efficiency, and that's taken into account by the code, and also material and design and adaptation. That it talks about reduce heat gains in building where appropriate. Some talks about locally sourced materials, which is one of the challenges around here, because many things are imported, but where appropriate, they encourage some of the Caribbean nations to use locally sourced material. So the code currently is not adopted in the Cayman Islands, but in developing the energy efficiency guidelines, we use a lot of the information from the code, and to make sure that the guidelines are aligned with the key CERBC requirement, in energy efficiency. So the scope of the CERC is pretty broad. Yes, go ahead.
Just 1 second. I thought I would send a quick poll just to see
sure.
how much people are familiar with the CREBC. So here it comes.
Yeah. Okay. So while that everyone is looking at the poll, sorry, and I see there's a hand up. Hussein, did you have a question or issue with the poll?
No, not any school. There's a question pertaining to the code. So I know here in Ghana we use NEC, and I think in most Caribbean countries also they use NEC. Maybe some other countries that I'm aware of, like Jamaica, they have another code that supports or work with NEC as well. The question is that all these codes here on the screen, the different chapters, will be extracted from the NEC, or it's something from another code itself that was designed?
Hey, Alex, are you able to hear better than I am? I am. It has something about the alignment of the codes. Is that right?
No, for me as well, the sound was cutting off a little bit, Hussein. Are you able to repeat? Try again, maybe.
Yeah, you can hear me now?
It's
It's still coming in and out.
If you want, you could type your question in the chat as well.
Well, I'll go ahead and talk about alignment, but yes, so what the CBERC is aligned with the International Building Code, and especially on the the other parts, but now because the energy efficiency portion is not adopted in the Cayman Islands, we're putting in measures that eventually will help builders familiar themselves with the code, and then eventually, if the code's adopted on Cayman Islands, it's not going to be something of a surprise or a challenge for builders to comply. And the code it's actually suitable for both commercial and residential buildings, and we just focus on the residential portion of the code. And the code, as I mentioned, the CARICOM objectives for the code include to conserve energy over the use of life of each building, because many buildings, when they're built, they'll stay active and operational for 30, 20, 30, 40 years easily. And so whatever equipment and electrical appliances that go into these buildings tend to be there for a long time, and over their lifetime they will end up using a lot of energy if we don't put the most energy efficient equipment and design possible to start with. Another key emphasis for the code is, of course, to provide flexibility for innovation. This is because, and they'll do that. I'll go over how the code provides that sort of flexibility. But the idea is that everybody's needs are different. And even in the Caribbean, different localities need different things, or they have access to different types of material, for example. So that the code does provide flexibility for innovation, maybe some new, wall or roof materials can be used, what have you. So they hopefully account for also future innovations and materials and things that builders come up with. So we'll talk about this in a little bit later, but it also has an above code provision, which allows builders to go above a code or use alternative alternative approaches, maybe different local. This might also apply to Hussein's question, which is maybe local programs, local builder, local or national requirements may be different. So it allows for those different approaches as well, as long as they're approved by local code officials or meet some of the mandatory requirements. Here's a graphical representation of how you can meet the code. There's different pathways, and I'll talk about that a little bit more in the different slides. But so yes, there's a simplified compliance. There's also the alternative performance path. So there's different ways that builders can meet that. So it's not completely rigid. You can, there's some trade-off that you can make during the building process, depending on what materials you have at hand or the designs that you choose to you choose to adopt. So these are the 4 paths that the graphical representation showed. So there's the simplified prescriptive path, which requires basically you just stick to the code and meet all the code requirements, minimum level of insulation, window performance. It's probably the easiest path, but it also, it means that you have to conform to every requirement. The prescriptive path is the same, but it does allow for some trade-off between building components as long as the overall energy efficiency design is achieved. There's also the simulated performance path, which allows for energy modeling software. And you can use that to show that your proposed design, because some of the designs might use different approaches, orientation, what have you. So it will allow for that. And then also there's the last one is the ERI, the Energy Rating Index, which is achieving a specific ERI score relative to reference design. So, each of these paths has different documentation procedures. And of course, as I said before, builders should choose the path that is aligned with their goals and resources, whatever it's available, what materials that they have, that you have, and the design that maybe your clients require. So maybe they want a lot of windows, and which means you have to do some other trade-off. I want to go over the mandatory provisions just quickly, because that's that can be the most direct path to compliance, and it has requirements on building envelope, right? So the proper insulation levels and air sealing to minimize heat transfer and also air infiltration, and the air leakage is a related factor to that. So testing has to be done. So you have to do the blower door test to make sure that the leakage rates don't exceed specified limits, which will cause challenges in indoor comfort factors and also energy loss. Duct sealing and insulation. So duct sealing is an important factor in maintaining system and equipment efficiency. Proper level of insulation, of course. The mechanical systems installed, well, ventilation and air conditioning, there's no heating required really, and water heating equipment that meet or exceed the efficiency rating. And lighting is important as well. We have now fully transitioned into LEDs. They're available. There's no need to use incandescent or anything else at this point. So the code actually has lighting requirements as well. So in terms of documentation and verification, builders have to maintain all of the documentation in order to show that they're compliant. Things like insulation values, window ratings, equipment nameplate, all of that. There's a compliance checklist in the code. There's a testing report provision. So if you do blower air testing or other sorts of testing, that's documented results. And so that, all of this facilitates the inspection process. So eventually the buildings will get inspected, and whether or not they're compliant with the code, it'll help the inspector and makes the inspection process a lot easier. There's also, again, there's a provision in the code for mixed use buildings. So, there's some buildings that are being constructed that has both commercial and residential use. And of course, I had already mentioned the above code program, so that builders who choose to go above or have approaches that are beyond the requirements, there's no need for that. There's no need for them to be discouraged by not using the code. Programs such as the LEAD program, that's above code, that the Leadership in Energy and Environment Design. There's the basically the code provides minimum requirement, but it does encourage going above code or innovative approaches. So we had talked about the Resembit program. There's the energy audit and retrofits. That we based a lot of the retrofits on the guideline requirements or the code requirements, and so it has shown significant result, as we can see in the video. So it really is an effective instrument for builders to use and consider when they starting their design and development process, and also for during the construction process. That should be the end of the code presentation. I'll stop here, and I welcome any questions. How about that, Alex? I put everyone to sleep. All right, so I'm gonna hand it over to you to see if you can wake everyone. Oh, do we have a question? Great. Mario, please, you have your hand up.
Hey, sure, Tony. Good morning. Good morning to you.
Good morning.
Well, basically, I just wondering whether the program that we are going through in the Cayman Island, is this energy efficiency is a subset of LEED?
Is energy efficiency a subset of LEED? Yes. I think a LEED building has its own requirements, but one of the many of the requirements for LEED actually is energy efficiency and sustainability focus. So the LEED actually has its own checklist. So energy efficiency, lighting, orientation, heating, ventilation, all of those requirements are also part of LEED. So the code, I would say, is the first step to getting to LEED. The LEED process can be challenging. I don't know if unless you're building a home, like a specialty home for a client that really demands to have LEED certification. It's usually more applicable for commercial buildings. But so meeting the code is the first step. But then the above code and going to LEED are the additional steps that you can build on meeting the code.
Right. Thanks for clarification.
Sure. Hey, Alex, I see here there's a question on the ROI on the 10 test home. Did we do any ROI? There's some payback. I think we did some payback estimates, but I don't think we actually calculated the ROI on the Resembit homes.
No, and thanks for the question, Jonathan. I think we have the information to give you a sense of the ROI. We don't have it on hand, but we could take note of that and ensure that we could include it in the slide deck that will be posted online, so you'll be able to see that.
Need to take a quick break or anything before you start, or because we've been going for a little bit, or do you
I was going to suggest that we take I don't know, maybe like a 10-minute break or something for everyone to. Is that too much? Should it be less? What does everyone think?
No, we don't have a poll for that.
Okay, let's take 10 minutes, and be back at less time. Okay, 5 minutes then. Let's be back at in 6
10
minutes.
after. Yeah, 10
10
minutes after. Yeah,
Yep.
10 minutes after. Okay.
Perfect. Right back. Welcome back, everyone. Can you see my screen?
Yes, we can see your screen.
Great. Very quickly, I'll just introduce myself, Alex Garro. I worked with me and Stephanie on the training, the guidelines, the homeowner infographics that we prepared as well in collaboration with the ministry. I had the opportunity to travel to Cayman for 10 days to meet with several stakeholders to get their feedback on the state of the construction industry in the residential sector and to get their inputs on what would be the lowest hanging fruits in terms of improvements for energy efficiency in homes. And so all that feedback was really helpful, and we used it in coming up with these guidelines and this training. So for this next section, we'll be looking at higher level design strategies for new construction. And I'll just add, we mentioned this, but I'll repeat it. Some of these measures are either only applicable for new construction. In some cases, they're applicable for retrofits, and in many cases, they're applicable to both cases. The overall approach that we recommend has three main elements. So the first one is the bioclimatic design and kind of a passive approach to high performance envelopes. And then we have to consider energy efficient systems and appliances, including air conditioning, and finally, renewable energy integration. So for this section, we will be looking at the first of these three segments, which is bioclimatic design and high performance envelope. What we mean by these, so for bioclimatic design, the goal is to adapt buildings to the local climate and take advantage of the existing natural resources and features. And this is nothing really new. This is how people have been building homes for several centuries. They've been just adapting how they build to their local environment. And some of that throughout the world has been lost with new technologies and building science and stuff. But it's important to keep in mind that a lot of these approaches exist already, and we just need to adapt to what's there. The second element is the passive design approach. The point here is to optimize the thermal performance of the envelope to reduce heat gains and air conditioning needs. So what do we mean by passive? Passive is in comparison to active systems. So before thinking about air conditioning and ventilation and any active systems in the home, we look at what we can do passively to increase the energy efficiency of the home. So relying on the architecture, orientation, and things like that. A bit more detail now on bioclimatic design. One of the key elements is to carefully choose building placement on a building site. So we want to take advantage of the existing trees to provide shade, use the plant native vegetation to increase foundation stability, use existing slopes to manage rainwater runoff and prevent flooding. Another element that we consider when we use a bioclimatic design approach is the orientation of the building. And the goal here is to minimize direct sunlight getting into the home and increasing heat gains and then increasing the need for air conditioning. So typically for tropical climates, we want to minimize or put the long axis of the building along the west-east axis to expose smaller facades to strong solar radiation at low angles. So when the sun when it's early and when it's late at night, the smaller facades won't get as much heat gains from the sun. And then a bit more detail on the passive design approach. Again, here the goal is to optimize the thermal performance really from the earliest stages of design. So when we think of the shape of the house, the wall section, window distribution, types of windows. So for instance, we want to consider shading, especially on the east-west facades, whether it be natural shading with trees or with shading devices with um, hurricane-proof overhangs, for instance. So really the first step here is to optimize the architecture and the features of the building, and thereby reducing the ventilation and cooling needs, and helping to maintain a comfortable indoor environment for people. And so another way to do that is to really think about how we want to insulate the roof and the exterior walls. Like I said, we want to place windows in a way that we minimize the amount of sunlight, solar gains inside the house, but still have enough natural light. When it comes to window performance, what we're looking for is mainly well-insulated window frames. In terms of glazing, it's not really worth going for double glazing. In many cases, single glaze windows can be sufficient as long as the frames are well insulated and we have low E glass or tinted glass to reflect a lot of the sun rays. And then another way that we could improve energy efficiency by just thinking of high-level design, high-level architecture is high albedo exterior finishes. We'll get into that a bit more later, but essentially is just making sure that we choose colors and materials for the exterior of the house that reflect as much sun as possible, instead of absorbing it, which would then increase the temperature inside the home and then increase the need for air conditioning. And we also like to consider in these cases the building shape. So in general, a compact building is better. So as opposed to a longer building, a more compact shape will be more efficient. But these things obviously depend on the context. Not all of these things can be achievable for every project, but it's just some things to keep in mind. And just an overview, just to make sure that everybody understands what we mean when we talk about the building envelope. It includes the roof, the walls, the foundations, the windows and doors. And the point of an energy efficiency building envelope is to minimize the heat transfer between the outdoors and the indoors. Sure, most of you already know that very well. Just want to make sure that we're talking about the same thing going forward. Insulation is definitely one of the most cost-effective ways to increase energy efficiency. There's currently no mandatory insulation requirements for new buildings in Cayman. And so, going from no insulation to good insulation can have a huge difference on electricity costs, especially insulation in the roof and attics. It can really reduce the need for air conditioning, increase comfort. And one thing, we'll get back to it in some more detail about the types of insulation, but keep in mind that there's a lot of several materials exist in different shapes and different forms. There's not one perfect solution for all projects. The right choice depends on the specific project. But one thing is really important is to always install insulation properly, depending on the type. Because incorrect installation could definitely potentially cause issues like lower performance and potentially high levels of humidity in certain areas of the house and potentially mold. So proper insulation is always really important. Typically in hot and humid climates, up to 40% of the cooling loads can be attributed to heat gains through the roof. So in a climate where there's a lot of sun, I'm sure many of you know that the roofs can get, the attics can get very, very hot. So that's, the heat that gets directly transferred into the living space. In some cases, we'll see some minimal amounts of insulation between, like along the ceiling plane, so between the attic and the living space. That will limit some of that heat transfer, but ideally, we want to insulate that very well so that, well, first of all, if you have an AC unit with ducts going through the attic, if the attic is very hot, then these ducts will get very hot, and then they will decrease the efficiency of the air conditioning unit. So isolating the roof also has another indirect impact, whereas it reduces strain on the air conditioning unit. What we recommend for an R value in the roof is R30. This is aligned with the CREEBC requirement. Based on discussions that we've had, this is achievable for many projects, and insulation can be installed using various materials. It could be along the roof line with spray foam, for instance, or along the ceiling plane with bats. Again, several materials exist. It's really important to just choose the right one for your project and install it properly. Before going forward, I have a little poll that I'd like to send out. One moment. There we go. Okay. Getting a lot of sometimes. Mostly sometimes. Okay, good. Meaning that it's not, if we were to uniformize this, standardize this across all new construction, it wouldn't be a huge leap since it seems to be already fairly frequent in projects. Thanks for participating, by the way. That's interesting, and definitely it's nice to see people being engaged. All right, moving on. Yeah, a bit more information on the types of roof insulation that exist. Like I said, several materials can be used for a given application, for a given project. It depends on your needs. For instance, if you're going with spray foam, you have the choice between open cell and closed cell. Open cell will allow water to go through, whereas closed cell spray foam will not allow that. So for instance, if you're applying closed cell along a wooden structure, then if ever there's a roof leak, you won't be able to see it because the closed cell spray foam will trap the water and prevent the water from going through. So you might, well, first of all, you might not know that there's a leak until quite a bit of time has passed, and then by that time there might be mold or damage to the wooden structure. So this is just to say you need to think about which type you use for which case. Also, for instance, open cell spray foam will require more thickness, so you need more room to achieve the same level of R value compared with closed cell. So you need to take that in consideration early in the design stage if you want to use open cell, for instance, to make sure you have enough room in the cavities for that insulation. Other types include rigid foam boards, cellulose, fiberglass, which could be either in bats or blown in, and same for mineral wool. They come in bats as well. My understanding is that most of these materials, maybe less so cellulose, as far as I know, but most of them are available on Cayman. And as we mentioned earlier, the government has waived import duties on several energy efficient materials, including insulation. This table here is just to show, to give you an indication of the required thickness that you would need for each of these insulation materials to achieve an R30 insulation level in the roof. The point here is not for you to remember this. It's just to know that, again, depending on the material, you'll need to adjust the size of the cavities and plan accordingly. And you'll be able to refer to this table. It's included in both the guidelines and in these slides, which you'll be able to refer to at a later time. This was maybe a slight mix-up in my slides, but this works as well. This one is just to mention that, so roof insulation is probably what has the most impact because there's a lot of sun, because roofs get superheated. So insulating the roof is what will definitely be one of the most cost-effective ways to reduce energy consumption. It'll have a really big impact, and we'll get to it next slide. But exterior wall insulation is also very important. The CREBIC contains requirements for exterior wall insulation, and we recommend that the guidelines would recommend that you follow these requirements. They're not cited here, but the code will give you some indications based on depending on the type of wall structure. There's different types of R value requirements. The table here is just to give you an overview of various wall sections that can exist and what kind of R value you could achieve with those. These are just ranges. They could change depending on the amount of insulation and other factors. So among the most common ones, you have ICF, insulated concrete forms, wood framing with insulation, concrete blocks, brick, and so on. At this stage, I will one more time rely on your great participation for one more poll. Where's that one? Oh, there it is. So on average, by how much do you think electricity consumption can be decreased when you add R30 insulation in a roof? This is based on your own experience, your own knowledge. Just it's a bit of a game to see what people think, and then I'll show you what we saw with the 10 NHDT homes. Okay, mostly. Yeah, good point, John. Depends on the current roof. I should have mentioned that. I think most of these homes already had a small amount of bad insulation along the ceiling plane, which we saw with the energy audits that we performed. In many cases, that insulation was had been moved around a little bit with storage and whatnot. So I don't think it was very, very effective in doing its insulation work. But there was a little bit of insulation, let's say, and it depends on the type. I think this was open cell spray foam, but good points. Definitely a lot of variables can affect the results, but this was just to give you an idea. And then the next slide here. So this is something that Kristen spoke to earlier a little bit. Earlier, she showed results for one single home. This graph shows the total average savings for all 10 homes combined. So those are averages. So in blue, you have electricity consumption on average between February 23 and January 2024. And in green, you have the next year, so February 2024 up until January 2025. The little numbers in teal, the percentages show the average savings year over year for each month. And then the two callouts. So the first one is on average, most of these 10 homes got their roof insulation upgrades somewhere in June, sometimes early July, but mostly in June. So you already see, but it was like maybe late June. So you see some savings in June, but not that much compared to the following months. And then the AC upgrades took place usually late August. So that tells us that savings that we see in July and August are mostly attributable to the insulation upgrade. So based on that, we can conclude that adding R30 in these attics generates savings of the order of, let's say, 15 to 20% year over year. Granted, this is not a huge sample size, and you could make corrections for weather if it was a hotter year this year versus last year or vice versa, but it still gives us a good indication. The results are pretty clear. The insulation already generates a lot of savings, and then if you look after the AC upgrade, you also see a lot of savings and they're consistent, which is interesting as well. Another key element, so going back to passive design, another key aspect that we consider when designing a home is the air tightness. So briefly, air tightness refers to the resistance to air leaks through the building envelope. So air could leak through maybe openings or cracks around the windows and doors, or penetrations through the envelope for wiring, for ducting. There could be, so all of these add up and allow some level of exchange between outdoor and indoor air. And if not properly sealed, then you just end up getting a lot more hot and humid air infiltrating through to the house, which will increase the need for air conditioning. And so an airtight envelope is important to reduce that infiltration and then reduce AC needs. Like anything, achieving air tightness, there's not one perfect solution. It depends on the project, depends on available materials and constraints. But in general, it's a good idea to try and have a continuous air barrier over the entire building envelope. It's a good idea to try and properly seal the breaks and joints in the barrier, so around the windows and doors, around the connections between foundations and the walls, or walls and roof, for instance, and to seal the gaps around the windows and doors. Those are simple ways to ensure a very good level of air tightness. You don't need perfect, but just we want it to be as good as possible with some of these methods that are not necessarily super costly, as long as they're thought about earlier on in the design stage. Another key element of passive design, we have the high performance fenestration. So windows and doors are major contributors to heat gain. So it's important to think about where we put them. Obviously we want a lot of natural light, but we don't want to gain a lot of heat. So we don't want windows and doors where there's the most sun exposure in the house. So in general, try to limit windows on the east-west facades to reduce exposure to intense low-angle sun. and try to use natural shading or shading devices as much as possible. When it comes to windows and doors, yeah, I mentioned this. I'll go over this fairly briefly. So we have two key elements to consider. On top of the placement, we have the type of glazing, so the glass, and the type of framing. So in terms of glazing, we try to go for low emissivity, low E coatings that reduce the heat transfer by reflecting the infrared radiation, but still allowing visible light to go through. So this property is measured using the solar heat gain coefficient. It's HGC. So this, I'll show you, I think, next slide. We go into the metrics a bit more. So for glazing, yeah, low emissivity coatings, and then trying to go for safe and durable glass. But I'm sure all of you are familiar with that. And then for framing materials, trying to go for well-insulated frames to reduce the heat transfer and prevent condensation around the windows. And insulation for windows, typically we use U values instead of R values, which I'll spare the more technical, the more math-y explanation, but it's just the inverse of the R value, but it's just convention in the industry. So for Windows, we use U values instead of R values. And again, yeah, I use an airtight insulation. A quick word on these metrics. So the U value, like I said, measures the heat flow between the outside and the inside. So the heat flow going through the window. So like I said, U value is the opposite of R value. So in general, we want a high R value for walls, but for windows, we're looking for low U value. So a low U value means better insulation in the case of windows. And when we look at the reflectance or the ability of windows to reflect infrared light, the solar heat gain coefficient, that's a number between 0 and 1, so it's a percentage. So a lower number indicates less heat gain and a higher number indicating more heat gain. In this table here, we're just presenting the recommended values for those metrics, so the U value and the solar heat gain coefficient. These are based again on the CREEPC code. I won't go into too much detail, but these could be good a good way to kind of direct your thinking when you're choosing windows. Another aspect of passive design, so energy efficient architecture, is the high albedo exterior finishes. High albedo finishes tend to reflect more sunlight and absorb less heat. And so they reduce daytime heat flow into the building. Typically, to achieve high albedo, which is also called solar reflectance. So high albedo means that the material, the roofing material or the exterior wall material will reflect more sunlight instead of absorbing it. So one way of doing that is by using light colored or reflective exterior finishes and materials. I think doing, trying to go for high albedo finishes is one of the most cost-effective ways to reduce consumption. According to the US DOE, we can reduce energy consumption by 10 to 15%. And in many cases, it's just about picking a different color for your exterior finish or for your roofing materials. So this is an easy way to really increase the energy efficiency without spending too much more. In some cases, a roof that has a high albedo index is called a cool roof. so this is just, I'm just wanting to show you a little schematics of what a cool roof does. And so essentially, high albedo means that it will reflect sunlight, it will release heat instead of keeping it. And this is what is illustrated in this image here. So light-colored roofs, for instance, will just reflect back light into the air instead of absorbing it, and whatever heat it does have, it will release it more easily than lower albedo materials. And like light-colored materials or light-colored roofs can be available in many types of roofing materials or many types of exterior finishes. And there's even now new types of coatings and materials that exist that allow to get high solar reflectance and high thermal emittance in other colors than super light colors. But typically, lighter colors are the easiest way to go. All right. That was it for the first element, the bioclimatic design and passive design approach for high efficiency envelope. Were there any questions at this point? Oh, I see I missed a few points in the chat. Michael, you asked what will be the target ACH. You could correct me if I'm wrong. I don't think the Quebec has a target ACH. Or maybe it has a target ACH depending on the wall assembly or depending on the building type. But currently the guidelines don't have a specific target ACH. And in some codes around the world, I've also seen situations where there are no specific air changes per hour, for those who don't know, so which is the metric to measure air tightness in a building. There is oftentimes no specific requirement, and in many cases, the code will just require that windows be sealed properly, all envelope penetrations be sealed properly, and this is validated through building inspection. So the inspector will go on site and check that these things are well sealed, and will then say, okay, you pass the inspection for air tightness without having to do an air tightness test, for instance. All right, I would then pass it to you. Talk about air conditioning efficiency.
Okay, well, actually, there was some exchanges in the chat, and so we tried to address that. But yeah, I think there were some questions about AC and ductwork and air tightness. And we'll go through all of that in a little bit more detail. But yes, you're right, Alex. There's no in the guide. There's no target air change per hour that we've recommended, because it will it depends on the approaches and the sealing and all of that combined. So. Okay, so there's no other discussions or
quick question, Kristen here. I just noticed a thing about the recording limit. Would this be a good time to pause and then restart the recording so we don't lose anything?
Yeah, I guess so. Yeah, I think that's the recording limit. It's actually on Kieran's recording limit. I think we're still going okay, but yeah, I can do that. I can stop now and restart the recording so that we'll just have two parts. Yes,
Yeah, it looks
I'll go
like
ahead
it's
and do
on
that.
yeah,
Just to make sure. Yeah.